Assalamu alaikum to everybody.
Alaikum Assalam.
Audibility is clear to all of you.
Yes, sir.
Yes.
Okay, nice. In the previous class, we were discussing about Dalton's law of partial pressure, and then we have done Gram's law of diffusion. Today, we are going to discuss problems based on that one. And your Sunday syllabus will be up to Gram's law of diffusion. In Sunday's examination, the total syllabus will be gas laws from the beginning, introduction to gaseous state, characteristics of gaseous state, measurable properties of gaseous state, Boyle's law, Charles law, Avogadro's law, Gay-Lussac's law, PV is equal to nRT, ideal gas equation, application of ideal gas equations, and then Dalton's law of partial pressure and Gram's law of diffusion. This will be your Sunday syllabus. Now, come to the questions. Question number 1. Calculate total pressure. Calculate total pressure, P total, in 10 liter cylinder. Volume is equal to 10 liters. Which contains 0.4 grams of helium, 1.6 grams oxygen, and 1.4 grams of nitrogen. At 27 degrees centigrade. Also find partial pressure of helium. Dalton's law of partial pressure. Also find partial pressure of helium in the cylinder, assuming ideal behavior. This word assuming ideal behavior is not necessary in the question. Remember that we deal all the problems of ideal behavior. However, when we go to the last part of this chapter, there we talk about real behavior also. Okay, now when you are having this discussion, it is very simple, sir. First of all, what he is saying, total pressure. Come on, how to go for total pressure? Very simple, sir. PV is equal to nRT. Whenever we are discussing this part, remember, this is number of moles of a gas, this is pressure of a gas. If it is pressure of two gases, number of moles of two gases, it will be total pressure of two gases. Therefore, whenever we are using ideal gas equation to find out total pressure of system, then we should take like this, sigma n RT. Total pressure is my job. Volume must be in liters, available in liters. Number of moles of all the gases. What is that? Weight by molecular weight. 0.4 by atomic weight of helium plus 1.6 by molecular weight of oxygen plus 1.4 by molecular weight of hydrogen. This is called sigma n. N1, N2, N3. Number of moles of helium plus number of moles of oxygen plus number of moles of nitrogen into R 1 by 12.18, or if you want to enjoy 0.0821 into temperature 300 kelvins. I got it. Now, once you find the value of pressure, this is called total pressure of system mixture of gases. Fine. Now the question is partial pressure. How to go for partial pressure? Go back to our notes. Partial pressure of a component of solution is total pressure of system into its mole fraction, Therefore, partial pressure of helium, you know the value of total pressure from here. Number of mole fraction of helium is number of moles of helium by total number of moles of all. Total number of moles you can add from all these things, right? You people are genius, therefore you can say directly, sir, number of moles of helium 0.4 by 4, 0.1 by this is 0.1 0.1. This is okay. I'll write here 0.4 by 4. Answer is 0.1. This is helium. 1.6 by 32. This is 0.1 by 2. This is 0.05. And this is 1.4 by 28. Answer is 0.1 by 2. That is also 0.05. 0.05, 0.05, 0.1 and 0.1. That is 0.2, right? Total number of moles. To find out mole fraction separately like this. However, you people are genius, you can go ahead for calculation. This is called dash atmosphere. Go ahead. Shoaib is saying total pressure is equal to 0.4926. Very good. This is 0.492. And partial pressure of helium 0.246. Very good. Anybody else? Nice. Saidur Rahman, got it. Very good. Correct. You are right. Partial pressure is 0.2463. Right. Shall I proceed? Okay, Laik Ahmad, correct. You are right. Correct. Very good. Nice. Now, come on. Equal weights of methane. Carb, is it over? Equal weights of, nice. Go ahead. Methane and oxygen are mixed in empty container of 1 liter. Volume is equal to 1 liter at 27 degrees centigrade. We should take temperature always in kelvins. Now, question is, he's asking two statements. Number one, partial pressure, no, fraction of total pressure exerted by oxygen. Fraction of total pressure exerted by oxygen. B, total pressure if weight of gas is 32 inch. No problem. That is not necessary. Duplication of problem. You people are genius. One problem is sufficient for that. Come on. What is asking? Fraction of total pressure means partial pressure. Fraction of total pressure means partial pressure. But whenever we are having this type of situation, first of all, we have to go for what we can say total pressure. What is total pressure and then what is partial pressure? For that purpose, I'll go like this. Partial pressure is equal to partial pressure of system. Directly you can take as a mole fraction into total pressure. Come on, partial pressure of oxygen is equal to PT. I don't know. No, sir. We know it because remember that whenever he says fraction means something out of 1. Whenever he says percentage, it is something out of 100. So it means indirectly he is saying something like this into. Now, what is this? This is supposed to be number of moles of oxygen by number of moles of oxygen plus number of moles of methane. Now he is saying equal weights. It is your choice to take any number, or you can say W gram. Suppose, for example, if I take W gram here, so weight by molecular weight, oxygen plus weight by molecular weight, methane, 1 into, this is supposed to be W by 32, right? This is 1 by 32 and W by 32 and W by 16. Simplify and substitute. I hope it is something in terms of 1 by 3. Come on, let us go ahead. Yes, it should be 1 by 3 because it is half plus 1. 3 by 2 and that will be cancelled. One by 3, correct? Next, a gaseous mixture of oxygen and nitrogen. This is your job. A gaseous mixture of oxygen and nitrogen in the ratio of 1:4 by weight. If weight of oxygen is taken as 1, it will be, this is x, it is 4x. Wajid, what is the problem? Which question we have to repeat you are saying? Question number 3, mixture of oxygen and nitrogen. Mixture of oxygen. It's over, but a second is over. Come to here, come to this side. In second question we have done and our solution is also over. Equal weights of methane and oxygen are in 1 liter container at 27 degrees centigrade. Find the fraction of total pressure. Come on. Ratio by weight of 1:4. If weight of oxygen is x grams, weight of nitrogen is 4x grams. Please be attentive in the class. Calculate the ratio of their molecules. This is not Dalton's law. Calculate ratio of their molecules, right? Mixture of oxygen and nitrogen are in the ratio of 1:4 by weight. Okay, no problem. What I do, suppose for example, I want to find out ratio of molecules. No, sir, I don't find ratio of molecules. I'll find out ratio of moles because 1 mole contains Avogadro number of molecules. Therefore, if you calculate this, automatically you get same answer because if you multiply Na and Na, that will cancel out. Okay. Now this is equal to weight of oxygen weight of oxygen x grams, weight of nitrogen go ahead. 7:32. Next, question number 4. Make a star on this question, especially doctors. 50 liters of dry nitrogen is passed through 36 grams of water at 27 degrees centigrade. After passage of the gas, there is a loss of 1.2 grams of water. Find vapor pressure of water. Very good question. Come on, I'm repeating the question. 50 liters of dry nitrogen is passed through 36 grams of water at 27 degrees centigrade. After passage of gas, there is a loss of 1.2 grams in water. Calculate vapor pressure of water. Now, this question is to be visualized properly. See how I am trying to enjoy that. Actually, what I do, I'll understand the question like this. There is a container in which I am having water. This is the water available, right? How much amount of water? He is saying that nothing is given. 36 grams of water is given. Okay, no problem. We talk it as in terms of weight. I don't want weight now at present. 36 grams of water is available. Now, suppose for example, listen carefully. Suppose for example, if I am having a piston exactly kept like this. Try to understand properly. A dark line. This is the piston available. Now I have taken the piston which is exactly touching to the surface of water. It means I am not allowing the water molecules from liquid state to convert them into gaseous state. That means indirectly, scientifically, I am not allowing evaporation process, right? I am not allowing evaporation process. Remember that every liquid has a property of evaporation. Every liquid has tendency to undergo evaporation, but I am not allowing that to do. Nice. After that, what I have done, I have taken a tube here, and through this tube, suppose for example, you are allowing nitrogen. Which nitrogen? He said dry nitrogen. And how much he said? 50 liters of dry nitrogen is made to pass through it. Now what happens? This nitrogen, it is not all said. I am visualizing the situation to understand, students can enjoy better. If this nitrogen comes here in this case, these bubbles of nitrogen will come and try to dance in the water molecules. And remember that nitrogen does not react with water at normal conditions. Therefore, there will be no chemical reaction, but it is a gas, and you are pushing the gas whole 50 liters and then it is blocked. What happens? If you are passing these 50 liters of gas, then this will push the piston up. Okay, now what happens? The piston will shift upward, and this gas molecule, remember, gas molecule always want to be in the free state. It will not be trapped into the liquid water. Therefore, it moves up and it goes take up the piston to this position. Something like this. Are you able to understand? Yes. Now this piston is here. This whole space is available with dash gas. Which gas? Nitrogen gas. No sir, no sir, wait a minute. As the nitrogen molecules are evaporating, piston is moving, water molecules also evaporate. Therefore, here the available gas is not nitrogen alone. This is nitrogen. Wait a minute, it is not visible properly. It is supposed to be nitrogen as well as water vapors. Therefore, now I should say, sir, this is known as which nitrogen? Moist nitrogen. Very good. And this is called as dry nitrogen. Right? The job is over. Now the question is, he is asking vapor pressure of water. What is this? It is water in the form of vapor. Okay, go ahead. Only PV is equal to nRT, only either nitrogen or only hydrogen, water. You cannot take mixture of both of them, because in the previous classes we have said gas laws are never applicable in case of moist gases. Dalton's law is applicable, but no gas laws. Okay, so I don't want pressure of whole system. I don't want what we can say vapor pressure of the system. I want vapor pressure of only water. Therefore, come on. This, suppose you are saying this is pressure of water into water, means water vapors in the form of gas, then volume. Now what is the volume? Remember this concept that if you are having a container of 50 liters in which we have one gas, what is volume of gas? Volume of container. Two gases, what is volume of each gas? Volume of container. Don't say half is for nitrogen, half is for water. No, they are not so disciplined type of students as you people are. They are having random motion. They are having least almost zero intermolecular modes of attraction. Therefore, I used to say one beautiful statement that most indisciplined form of matter is gaseous state, and more disciplined form of matter is solid state. Therefore, if suppose for example you are saying that there are 10 gases available in a container of 5 liters, volume of each gas is taken as 10 liters. Remember that point. Okay, so here in this case volume is equal to 50 liters even for water. Number of moles, if you want to calculate pressure of water, take number of moles of water. How many number of moles of water? He said loss of 1.2 grams of water. Why you have loss of 1.2 grams of water in liquid state? Out of 36 grams, 1.2 grams have been evaporated, right? Therefore, vapors 1.2 grams. Molecular weight, whatever be the physical state, molecular weight remains same. 1 by 12. I want to enjoy this 12 and this 12. Therefore, I have written 1 by 12 into temperature 300. Okay. Come on, go ahead. Rafe is saying 0.3. Rafe and Khizar, both of you are giving same answer. I'll give small advice to Rafe and Khizar. If you are two students, please write down JL4165 Rafe, another one 66 Khizar, and try to solve separately problems, because I think two students will have two different hall tickets. Saidur Rahman 0.03. Very good. Answer is 0.03. And this 0.3 is answer of whether it is Rafe or Khizr, I don't know. Ahmed Abrar, Muhammad Abrar, right. Ubaidur Rahman 1.6. What is the 1.6 beta? Yes, answer is 0.03. Very good, very good. Nice, nice. Come on, question number 5. Next question. Density of mixture of oxygen and nitrogen. Density of mixture of oxygen and nitrogen. Oxygen and nitrogen at STP is 1.3 grams per liter. 1.3 grams per liter. Density D should be decent. Come on, at STP. Find partial pressure of oxygen. Find partial pressure of oxygen. Okay, a beautiful question for IIT students. Make a star, right? And doctors, definitely doctors are smart. Therefore, we can also enjoy this question. No problem, right? Come on, how to proceed for this question? See here carefully. Wait a minute. Now, when you want to have partial pressure of oxygen, directly when I say the word partial pressure, you say very simple, sir. Partial pressure is equal to total pressure into mole fraction. Total pressure STP means 1 atmosphere, and mole fraction. Mole fraction means I want to have number of moles of O2 and N2. Okay, how to do that one? Yes, since density of mixture is given to you, once density is available, I can use the formula Pm is equal to DRT. Okay, what is pressure? STP. What is this M called? Mean molar mass, because this is density of mixture. So I can calculate mean molar mass is equal to density of mixture. 1.3 grams per liter is acceptable. 1 by 12.18 into temperature 273 kelvins. Remember this number is 22.4, approximation 22.42. All right, and these things are very important, especially for NEET students. These type of numbers are game where you can have less tension. Mean molar mass, I got it. No sir, once you know mean molar mass, it is M1x1 plus M2x2. This is for oxygen, this is for nitrogen. Mean molar mass, I know it. This is 32. What is mole fraction? X1 plus 28. What is mole fraction? 1 minus X1, because sum of mole fractions must be equal to 1. I got mole fraction of oxygen. Once I got this value, partial pressure of oxygen is equal to total pressure into mole fraction. Go ahead. What Saidur Rahman? 0.284. Very good. Very good. Nice. Mohammad Shoaib. Correct. 0.3. ठीक है चलेगा. Sheikh Junaid. It's 0.28. I don't have any objection to take 0.3 also, because I am having 4 options. I have to choose nearest one, so it can be also accepted. No problem. But in brackets write down correct answer 0.28. Okay, nice. Come on, come to next question. Shall I proceed? Question number 6. A jar contains a gas and few drops of water. Few drops of water. Nice. 80 kelvins. The pressure in the jar is 830 millimeter of Hg. The temperature of the jar is reduced by 1%. The vapor pressure of water at two temperatures, vapor pressure of water at two temperatures. Which two temperatures? This one and this one. At two temperatures are 30 and 25 millimeter of Hg. ठीक है? Find new pressure in the jar. It's not Gram's law for diffusion or Dalton's law, but we have slight application of Dalton's law here in terms of aqueous tension. Come on. How to proceed for this? When you are having gas here in this case and along with water droplets, remember that this gas is said to be dry gas when I have taken alone gas. But once I insert water droplets, then I have to wait for some time so that we have equilibrium. And after that, we can say, sir, this gas is now become moist gas, right? And in case of moist gas, we don't have application of gas laws. However, let us try to enjoy. We are discussing pressure and temperature. Therefore, what I should do? Nothing, sir. P1 by P2 is equal to T1 by T2. Right? But remember, be careful. This story is applicable only in case of dry gases. ठीक है, चलिए pressure P1. What is pressure P1? Initial pressure. Initial pressure is supposed to be 830. No, sir. This pressure is pressure of moist gas. Okay, whenever moist gas is given, remove the pressure of water, aqueous tension. This is Dalton's law. This is Dalton's law. Sum of partial pressures of gas and water vapor is equal to total pressure, right? Then P2. What is this P2? P2 is final pressure of dry gas is equal to T1. What is T1? T kelvins, right? Now I'll enjoy like this. Suppose if it is 100 kelvins, right? No, sir, I want to talk in terms of T kelvins. No problem. If it is 100, it should be taken as dash 99, right? If it is T, it is taken as 0.99 T. Anything, right? You people are genius. Now, once you're having this, then it is supposed to be 100 by 99. Find out the value of P2. What is P2? Sir, so many atmosphere. Is it the answer? Anybody? My question is it the final answer? Yes or no? सईदुर रहमान, सब्जेक्ट पे ध्यान दीजिए, नंबर पे ध्यान मत दीजिए. 830 minus 30 is equal to 800. नर्सरी के बच्चे भी बोलते हैं. प्लीज प्लीज, राइट? Concentrate on subject. Ejaz Hussain, what you are saying? No. Yes, he is saying this is not the final value because this is supposed to be the pressure of dry gas. Then I should say P dash is equal to pressure of dry gas plus I have to add now here. How much I have to add? New aqueous tension. Remember this one. Is it clear? Yes, go ahead. 817 atmospheres. Mm, Sohail is saying 817. Muhammad Imad, yes, 817. Very good. Yes, you are right. Correct. Nice. Next. Now, suppose, for example, see this question. I'm trying to create a question here. Let us see. I got an idea to create a question from this discussion. What is the question? Gas plus drops of water. Okay. At T kelvins, see the beauty of this question, and 830 millimeter of Hg, right? Aqueous tension at T kelvins is equal to, I'll just take the same numbers, 30 millimeter of Hg. If contents of jar are shifted completely to another vessel of volume half V, find new pressure. Okay, come on, enjoy this game. A beautiful question. First of all, try to read the question. Try to read the question, what he wants to say. Read the question. Yes, those who are able to do, please don't see the screen and try to enjoy your confidence. But those who are having problem, yes, I'm available with you. We are having a container in which we are having moist gas. Okay. Now he is talking about constant temperature, T kelvins, T kelvins. Nothing has been mentioned. Therefore, at constant temperature, which question you are asking, Shoaib? What is the problem? How it can be atmosphere? All pressures will be taken in millimeter. Which discussion you are doing? It's over, na beta. Last question. If it is an atmosphere everywhere, it must be atmosphere. If it is millimeter, it will be millimeter. ठीक है? चलिए. अगर वो मिलीमीटर में था क्वेश्चन में तो आंसर मिलीमीटर में लिखिए 817 मिलीमीटर. अगर वो एटमॉस्फेयर में तो एटमॉस्फेयर में लिखिए. उसके लिए अननेसेसरी वाई टू वेस्ट टाइम. Moist gas. When you are having moist gas, temperature is constant. Therefore, we can say, sir, P1 V1 is equal to P2 V2. चलिए. What is P1? Pressure P1. 830 millimeter of Hg. No, sir. 8 into volume V is equal to, once you are talking about P2, what is P2? Final pressure. If suppose, for example, you are talking about final pressure, I don't know final pressure, P2 is half of that value. Therefore, P2 is equal to dash. How to proceed? Whenever we are discussing this, remember that 830 minus 30, 800, 1600. This is supposed to be 1600 and millimeter, because it is given in millimeter. right? Now, is it the final answer? P2, sir, this is not the final answer. What is final answer? This is supposed to be the pressure of dry gas. I want to have moist gas. What is pressure of moist gas? Pressure of moist gas is equal to 1600 plus 30. Any objection? Anybody want to create some objection? Any doubt to create here? Try to analyze the previous question and this question. Right? What is conclusion of this question? Conclusion is change of temperature will change the aqueous tension. Change of temperature will change the aqueous tension, but change of volume will not change the aqueous tension. There also you have taken 30. Here also you have taken 30. In the previous problem, in the first case we have taken 30. In the second case we have taken as 25 because we are talking about temperature variation. Okay, all right. Mohammed Dabrar is saying, sir, how are we getting pressure of water vapor as 30? Excellent, boy. Please, Abrar, can I ask you a simple question? How I am getting pressure of gas plus water drops 830 millimeter beta? How I am getting 830? Come on, come on. Remaining students, please enjoy. 800 plus 30. कहाँ की बात कर रहे भाई? किधर है आप? कौन सी दुनिया में है अबरार? 830 ऊपर यहाँ लिखा हुआ है 830. ये 830 कैसा आया पूछ रहा हूं मैं आपको. दिस 830 आप बोल रहे ये 30 कहां से आया, तो मैं पूछी ये 830 कहां से आया? 800 प्लस 30 800 कहां से लेके आए? आपके पॉकेट में से डाल रहे हैं? कहाँ है अबरार? क्या पढ़ रहे बेटा? क्या सुन रहे? देखो स्क्रीन. अच्छा, व्हाट यू आर आस्किंग, वेपर प्रेशर 30 कहां से आया? हाँ, इट्स प्रेशर ऑफ गैस मिक्सचर. हाँ, इट्स प्रेशर ऑफ गैस मिक्सचर. सिमिलरली इट इज एक्वस टेंशन इज गिवन टू यू इन द प्रॉब्लम. जैसा आप बोल रहे हैं प्रेशर ऑफ गैस मिक्सचर है, ये बात समझ गए आप अच्छी तरीके से. वेरी गुड. When you are saying this is pressure of gas mixture, why don't you say this is pressure of water vapors? It is given in the question. अब वो गिवन क्वेश्चन को भी आप नहीं बोल सकते कहां से आया. उसके लिए रिसर्च करना पड़ेगा. ठीक है बेटा, चलो अल्लाह खैर करे. आराम से आराम से आराम से, डोंट टेक टेंशन. आराम से, बहुत स्लो जा रहा हूं मैं, आराम से. हाँ, जो लोग रेफरेंस नहीं करते हैं उनके लिए तो खैर everything is same, they can't understand. Those who are referring, they are enjoying, right? They are enjoying. आपकी क्लास में they are enjoying. रेफरेंस करने वाले, अटेंटिव रहने वाले डेफिनेटली एंजॉय करते हैं. ठीक है, चलिए नेक्स्ट. नाउ these are some of the problems with respect to Dalton's law of partial pressure and all that. Next. There is a question here, very good question. 1 liter of oxygen, 1 liter of oxygen, 1 liter of hydrogen are taken in a vessel of 2 liters. At STP. ठीक है. The gases are made to combine to form water. No problem. Find mole and weight of water formed. A bit. Mole and weight of water formed. B bit. Amount of gas left. खैर वो सब चीजें आ जाएंगे आपको. Total pressure, total pressure at 100 degrees centigrade, right? Moles of oxygen used during formation of water, right? Read the question. Till that time, I'll remove all the contents here. Sorry. Now, how to proceed? Very simple, sir. In this question, we are talking about two gases. Nice. We are having hydrogen and oxygen so as to give you water. बैलेंस कर लेंगे तो शायद आपको ऐसा बनेगा. चलो ठीक है. Now volume time t is equal to 0. When we are talking about volume, then normally what we can say, sir, here in this case we have one volume, here we are having 1 liter, here we are having 0 liter. Now recall that I am writing as if I am discussing number of moles. Yes sir, PV is equal to nRT. In this system, temperature is constant, R is constant, and pressure is constant. Therefore, we can say that volume is directly proportional to number of moles. Volume is not equal to number of moles. Volume is directly proportional to number of moles. Therefore, I can write as if I am discussing the problem in terms of mole in stoichiometric 111, right? Now, this is at which condition we are discussing. The given condition is to be as STP condition. No problem. Now, as we have done in case of number of moles, sir, for every 1 mole we require 2 moles. Therefore, for 1 mole we require 2 moles, not available, hence dash. I should not say moles here. What I should say, for 1 liter I require 2 liters, but it is as good as what I am discussing in terms of mole, because volume and mole are proportional to each other. This is limiting reagent. Therefore, volume left out is equal to 0. Okay, right? For 1 we require 2. We are having only 1, so it is finished. Now it is 1 available. Now this is limiting reagent. Make a star here. For 2 moles we require 1 mole. For 1 mole we require half mole. 0.5, not moles, liters of oxygen left out. Come to the question. Moles of oxygen used, half mole is used, half liter is used, half liter is left out. Half liter at STP, how many moles? You have to find out that one. Very simple. And then water formed. It is 1:1. This is in terms of volume. Therefore, we can say 2 liters of water is formed. If you are having 2 here, it is 2. If it is 1, this must be also 1 liter. So we have formation of 1 liter of water, but remember that he is to be considering this to be in the gas form. Remember, listen all of you carefully. At STP, water is not in the liquid state, not in the gaseous state. It is in the liquid state, but he is talking in terms of this. It has taken volume directly proportional number of moles, applicable only in case of PV is equal to nRT. Now, can you do the problem? Remaining moles and weight of water is formed. Come on, a bit. How to proceed? We got volume of water to be as 1 liter, right? Volume of water formed is 1 liter, but it is in which case? Gas form, right? He's asking moles. Okay, sir. PV is equal to nRT. Pressure STP. Volume 1 liter. Number of moles of water. ठीक है. Remember, repeatedly I am saying at STP water is not gas. He is saying like that, and therefore we are applying in this. R, and what is T? This whole number is 20.4. Number of moles of water. I got it. Weight of water, number of moles is equal to weight by molecular weight. You get weight of water. Come on. Total pressure at 100 degrees centigrade, PV is equal to nRT. Total pressure. Volume. Total volume of system. No sir, he is talking about 2 liters vessel. अब ये luckily 1 1 है 2 ऐसा नहीं है. It is 10 and 10 I have taken 2 liters, problem is correct. It is 1 and 1 I have taken 10 liters, problem is correct. It is 1 and 1 I have taken 0.1 liter, problem is correct. But final volume is volume of container. तो यहाँ क्या लिखेंगे 2. ये 2 1 plus 1 नहीं है, ये 2 1 plus 1 नहीं है. This is volume of container. Okay, is equal to, now here number of moles, total pressure, total number of moles you have to calculate and proceed. For that purpose individually you have to calculate the number of moles of each gas. पहले ये कर लो, बाद में फिर वो बढ़ा दो. First complete this part, then we'll proceed. Zero point 0.04 moles of water abroad. Okay, okay, very good. Right. 0.803. You are right. Wait a minute. Saidur Rahman and Muhammad Shoaib and Sohail Ahmad. There is some mistake in calculation of weight of water. Weight of water. What about number of moles? Shoaib, moles लिख के छोड़ दिए. कितने moles? चलिए. Abrar, you are saying 0.78 liters. ये कहाँ से आया बेटा? ये 0.78 liters कहाँ से आया? क्वेश्चन में लीटर्स कहाँ हैं? क्वेश्चन में लीटर्स कहाँ हैं? ओके, चलिए. नंबर ऑफ मोल्स ऑफ वाटर 0.4.46. कहाँ मिस्टेक से देखते जाइए आप. जो आपका कैलकुलेशन करे हैं वो मिस्टेक्स चेक कर लो. You are giving some wrong answer. 4.46 10 power minus 2 moles he's saying, and weight of water he says 0.08. जिसका बाकी का है सब गलत है, ऐसे चेक कर लीजिए. चलिए ठीक है. There are so many mistakes, right? You people are missing some decimals, and I think you are trying to do answer fastly. Fastness is not required. Fastness is not required. We are doing physical chemistry. We are not doing biology, botany, and zoology. Their fastness is required because there is no number game, memory game. It is number game and conceptual game. चलिए ठीक है. ये आंसर्स हैं, आए तो ठीक है, नहीं तो फिर से कवर कीजिए. In total, RT. In total का मतलब है number of moles of hydrogen 0. Number of moles of oxygen I had to calculate here because volume is 0.5 liters. I have to calculate it. Be careful. ठीक है. फिर number of moles of water, it is in the gas form. ये कब की बात है? 100 डिग्री सेंटीग्रेड की. सब कैलकुलेट करेंगे आप. यहाँ पे आया कितना? 1 लीटर. ये वॉल्यूम भी नहीं मालूम है. वॉल्यूम इज 1 लीटर. नंबर ऑफ मोल्स ये सब मालूम करने के बाद टोटल प्रेशर इनटू वॉल्यूम इज इक्वल टू सिग्मा एन. यहाँ से सब्स्टिट्यूट करेंगे इनटू आर इनटू डैश. Come on, go ahead. The previous answers are wrong. Leave it. Don't waste your time. Leave it. ये कर लीजिए, चेक करो, आंसर्स आई गिव यू। दो आंसर्स हो गए। टोटल प्रेशर बी बिट, (1.02 atmospheres). That will stop here. Remaining discussion will continue in the next class. Thank you. Is it over? Go ahead, go ahead. I think you're having other class. Go ahead. Total number of moles 3. I don't know, but a total number of moles. That will stop here. Remain, we'll discuss the next class. Thank you.